let's take a look at some more composites. Now that we know about pyramids, we can include composites that have pyramids in them. So it says find the volume and surface area. This composite is made from a rectangular prism with a pyramid on top. Okay, so they want the volume and they want the surface area. So let's get started with that. So first we're going to do the volume and then we'll do the surface area. And we need to have a plan. So if we want to do the volume of the composite, we need a plan. The volume of the composite. So I'm going to use a subscript of COMP to indicate volume of the composite. So what I want to do is I want to take the volume of the prism, the rectangular prism, and I'm going to have to add to that the volume of the pyramid. That's what I'm going to have to do. That's my plan. So if I get all the volume of the prism and then all the volume of the pyramid and add those two together, that'll be the volume of the composite. So that's my plan. All right, so let's go find those things. Let's go find the volume of the rectangular prism, Okay, if I go to my formula sheet and I look for volume of the prism, it's going to be length times width times height for a rectangular prism. So that formula is length times width times height. Now this is just of the prism. So if I look at it, I'm going to call this my length, and I'm going to call this my width, and I'm going to call this my height of my prism. And it doesn't matter which one I label as which for a rectangular prism, but once I label it, that's what I have to be consistent about using it as. So this is going to be my length, I said, was 13. My width was also 13. That means that's a square prism. And my height is 5. Okay, so 13 times 13 times 5 is going to give me 845. And our units are millimeters. So that's going to be millimeters, and it's volume, so that's millimeters cubed. So that's my volume of my prism. Okay, that's going to be one of my numbers. I'm not going to box that as a final answer because they want the volume of the composite, which we haven't found yet. The other thing we need to go find is we need to find the volume of the pyramid, And I think I'll change colors for this. I do want to keep all this together, but I want to make sure I know the difference between the prism and the pyramid. I want to find the volume of the pyramid now. So if I go back to my formula chart, volume of a pyramid, and this is a rectangular pyramid. Remember, we said the formulas are the same for all pyramids. They just put each one with a different picture. So 1/3 area of the base times height. So that's 1/3 area of the base times height. Okay, let's plug in. We've got 1/3. I need the area of the base of the pyramid, the area of the base of the pyramid. Well, the base of the pyramid is just the top of the prism. So the top of the prism we know is parallel to the bottom of the prism. Those are congruent. So that means this also is 13 units by 13 units. So the area of a rectangle, that area of the base of the pyramid, which is just a rectangle, is just length times width. So that's going to be 13 times 13. 13 squared, some of you probably know your perfect squared, so that's going to be 169 millimeters squared. And so now I'm ready to plug that into my formula. That was area of the base is 169. So I did the 1/3, I did the area of the base. Now I have to multiply that by the height of the, what are we talking about? The height of the pyramid. Now the height of the pyramid needs to drop from the center perpendicular to the center of the base. It needs to be perpendicular to the center of the base. And I don't know what it is. So we're going to have to find it. Do you remember how we find it? We're going to use Pythagorean theorem. So if I start to look at this triangle, I want to know the height. I already know the slant height. Which is L. Okay, this is, now remember, these are two different L's here. This was the length of our prism. This is the slant height of our pyramid, So what I need to know is I need to know the distance here from the center of the base to the center of the side. I need that distance right there. Well, since that's the center, it's halfway to, it's half the length of the side because it's in the middle of that whole side distance. So it's half the length of the side. So that would be 13 divided by 2 or 6.5. Since the whole side is 13, it'll be 13 divided by 2 or 6.5. Okay, so let's look at that triangle that we're trying to solve right now. I'm going to draw it down here. So height of the pyramid half the length of a side, which we said was 6.5, and then the slant height, which they gave us, the slant height of the pyramid, which was 10.3. Okay, remember, when we drop a height, we drop it perpendicular to the base. So we dropped that height perpendicular to the base, so that is a right triangle. If we know two sides of a right triangle, we can find the third side with Pythagorean theorem. Now remember, when we set up our Pythagorean theorem, the one across from the right angle is our hypotenuse. So I'm going to say h squared plus 6.5 squared equals 10.3 squared. Okay, so now we're going to use our algebra skills to solve that. I want to get the h by itself, so I'm going to subtract 6.5 squared from both sides. So on my calculator, 10.3 squared minus 6.5 squared is going to give me, let's double check it, 10.3 squared minus 6.5 squared is going to give me 63.84. Now, if we're rounding, that's going to be 63.8. 63.8. Okay, and that's going to be h squared. I'm kind of out of room here. We're really squeezing that in. So h squared equals 63.8. I'm going to rewrite that up here just so that we can kind of, where to put it? Okay, I think I'll squeeze it in right here. So I'm just going to rewrite it here. We've got h squared equals 63.8. All right, how do we undo that square? We undo a square with square root. When we take the square root of both sides, we pick up the plus or minus option. For geometry, we never want the negative option. The square root undoes the square. We get the height of the pyramid is, let's see, square root of 63.8. Square root of 63.8, and that rounds to, that 8's going to make that round to a 10, so that's going to round to 8. Okay, so the height of the pyramid is 8 millimeters. 8 millimeters. Now that's an approximate, so I'll make that approximate. Okay, that's that height of the pyramid, so let's drop it in. We said it's 8 millimeters. Now we're ready to go to our calculator and get the entire volume of the pyramid, which is going to be approximately, so if I do 1/3 times 169 times 8. So we're going to do 1/3, scroll out of the fraction, times 169 times 8. Okay, and that rounds to 450.7. That 6 is 5 or above, so we give that a shove up to 7, 450.7. So that's going to be approximately 450.7. Our units were millimeters. This is volume of the pyramid, so that's cubic millimeters. I need a second M in there. Let me see if I can fix that. I'll do millimeters cubed. Okay, all of that work, and we still haven't found the answer they wanted. We found the volume of the prism, we found the volume of the pyramid, but they asked for the volume of the composite. So what are we going to do with those two numbers? Well, we're going to follow our plan. We're going to take volume of the prism, 845, and add the volume of the pyramid, 450.7. And that's going to give me 1,295.7 millimeters cubed, or cubic millimeters, because this is volume. Okay, so the volume of the composite, a subscript of composite to remind us which volume we're talking about. The final volume, the volume of the composite, is approximately 1,295.7 millimeters cubed. Beautiful. Okay, guys, that was just finding the volume of the composite, just the volume of the composite. Now we want to go find the surface area, and I reserved this space because I knew we were going to need space for that as well. Let's see how that goes. So if we want the surface area, now I'm going to, I'll leave those things there, but let's think about this. So the surface area are the parts of the composite that you can touch, the parts that are still on the surface when you put the two shapes together. So if I think about this, I'm going to want the surface area of the composite, I want to make a plan. is going to be the surface area of the prism, the parts that are exposed. So it's going to be the surface area of the prism without this one base, without the one base, okay? So minus a base, because that top base, it's parallel to the base on bottom, okay? That top base is covered up. It's not on the surface anymore. They put a pyramid on top of it, so it's not on the surface. So I'm going to do the surface area of the prism without one base. That way it'll still include the other base and all this lateral surface area, so the lateral surface area and one base. And then I'm going to add to that, what part of the pyramid is on the surface? Well, not the base of the pyramid. The base of the pyramid is on the top base of that prism. Those are both on the inside of our closed figure now. Neither of those is on the surface anymore. What is on the surface is the lateral area of the pyramid. So I'm going to add to that the lateral area of the pyramid. That's my plan. Does that make sense? Does that make sense? We've got to have a plan before we get started. All right, so let's go find these different things. So if I want surface area of a rectangular prism, remember that formula says surface area of a prism is 2 length times widths plus 2 length times heights plus 2 widths times heights. Well, that first length times width is our base, and there were 2 of them originally, but we said we want to subtract one of our bases. The easiest way to subtract this base is to make it not a 2 anymore. We're not going to have 2 length times widths. We're only going to have the one that's still on the bottom surface. We're taking away the base that was on top. So that minus base we did by taking it from 2 down to just one of those bases. Okay, so let's find that part of the surface area of the prism. So that's going to be, the length we said was 13, and we're using these same labels, length, width, and height, that we originally decided on for our prism. So anytime we're dealing with the prism, and I should add those letters, prism, anytime we're doing the prism, we're using these labels for length, width, and height. So just the length times the width, which we said was also 13, plus 2 times the length, which was 13, times the height, which was, here it is, the height is 5. And I'm just following my formula, length times width plus 2 times length times height. So I'm on my last expression now, plus 2 times my width is 13, and my height of my prism is 5. Okay, that 13 is looking a little hard to read. It kind of looks like a B, so I want to make sure and clean that up real quickly. So we're going to call that, rewrite that. So 2 times 13. Okay, so let's put that in our calculators. If we put all of that in, we get that the surface area of what's still on the surface of that prism is now 429 millimeters squared. Why is it square millimeters? Because that's surface area of the prism. Now that's one of our answers, but it doesn't get a box because it's not the final answer we're looking for. That's just the first part. So let's go find the second part we need. We need the lateral area of the pyramid. So let's go find it. The lateral area, and I'll use the subscript. I got to say more than P because their prism and pyramid both start with a P, so I'll say PYR for pyramid. This was prism up here, and this is the lateral area of the pyramid. And if I go look at my formula chart, lateral area of a pyramid is 1/2 slant height times perimeter of the base. So that's 1/2 slant height times perimeter of the base. Now, how did I know that was slant height and not the length of the prism? Well, because I'm doing the pyramid now, and in the pyramid picture, L is the slant height. So I make sure I know what I'm finding, and if I'm not sure or get confused, I come check my picture and my formula. So that's slant height and perimeter of the base. Okay, so if I want to plug in, that's 1/2. Do we know the slant height? Ooh, we do. We already know it. The slant height up here, we labeled it so we could find it again. It's 10.3. So I'm going to put that in. And then I need perimeter of the base. Have we found the perimeter of the base yet? I don't see it anywhere, and I would have labeled it. So let's come find it right now, and we'll make sure that we label it. The perimeter of the base Now this is the base of the pyramid, and the base of the pyramid, we see those are 13 and 13, and that's a rectangle, so the other sides are 13, opposite sides are congruent and 13. So the perimeter is just going to be 13 plus 13 plus 13 plus 13. Perimeter is just adding up all the sides of the base. Or we could just say 4 times 13 since they're all congruent, and that's going to give me 52. All right, now that I have the perimeter of the base, I can plug that in. That's 52. If I check my formula, we did half the slant height times perimeter of the base. So I'm going to put that in my handy dandy calculator, and I get that that is 267.8. 267.8. That's area, so that's millimeters squared. Okay, and that's my second part that we needed. Okay. So now what are we going to do? Well, we've been working so hard. Let's go back and look what our plan was. Our plan was the surface area of the composite is the surface area of the prism without one of the bases, minus one of the bases, which we took off at the beginning, plus the lateral area of the pyramid. So let's take those two numbers. We said we're going to add them together. So we've got our 429 plus 267.8. And when I add those up, that's going to give me 696.8. And what kind of millimeters is this? Well, let's go back and look. We're finding surface area, so this is millimeters squared. You can box that final answer. The surface area of the composite. I'm going to put a subscript of composite to remind us which surface area that is. We are working up in here. Math is hard. I can do hard things. Okay, very nice. We just take it bit by bit. We make a plan, and then we start following the plan using our formula cards to help. Let's try one last composite. These are definitely the hardest that we do, putting everything together. It says, you try now. So we're going to let you try this one. So you can try this one on your own if you want, but I'm going to work it here as well. So you can pause the video and then come back when you're ready to see how you did. It says, find the volume. This composite is made from a cylinder with a hemisphere removed from the inside. Now that might seem a little funny, but you actually see shapes like this all the time. If you've looked at the bottom of a hairspray can, the one that's a spray bottle, an aerosol spray, the bottom of it is a hemisphere removed. So it's got like a domed base on the inside, but that hemisphere has been removed. Okay, so when we want to know volume, that makes sense because we want to know how much still fits inside of it with that hemisphere removed. So the hemisphere is half a sphere. Okay, we got to make a plan if it's a composite. So my plan is going to be to find the volume of the cylinder. And I want to label this what this is going to be. This is going to be the volume of the composite. The volume of the composite will be the volume of the cylinder. And are we adding or subtracting that hemisphere? Well, it says the hemisphere was removed. Removed means we're subtracting a hemisphere. Now, the volume of a hemisphere is literally going to be half the volume of a sphere, half the volume of a sphere. And I want to use the volume of a sphere because that's on my formula card. Our formula cards do not have hemispheres on them. So we're going to have to just do half the volume of the sphere. So that's my plan. So let's go do that. Let's go find volume of the cylinder. And if I look at my formula card, here's my cylinder. Volume is pi r squared times height of the cylinder. So that formula is pi r squared times height of the cylinder. And then I'll go find half the volume of the sphere. That's what I'll do next. Okay, and then we'll subtract those two. So if I want to do the volume of the cylinder, we said it's pi, and I need my radius squared times my height. Wah, wah. They didn't give us the radius. What did they give us? That's the diameter. It's not too hard to find it. Remember that the radius is just half the diameter, or the diameter divided by 2. So half of 7, or 7 divided by 2, is 3.5. 3.5. So I'm going to label that as my radius so I can find that later. So that's 3.5 squared, and I need my height of my cylinder. We're doing the cylinder, so we want height of the cylinder, and here it is. That's my height of my cylinder, 5.5. If I put that in my calculator using the pi button, pi times 3.5 squared times 5.5 is approximately 211.7. 211.7. Do we have units here? I do not see units. Okay, so in our final answer, we'll use generic units, but we don't have to write them here. If I wanted to, this would be units cubed or cubic units. All right, let's go find half the volume of the sphere. I know starting off, it's going to be half of whatever the formula for the volume of a sphere is. So let's go find that formula. So on our formula charts, there's my sphere. Volume of a sphere is 4/3 pi r cubed. Okay, so we've got 4/3 pi r cubed. Now I know your notes does have formulas for the hemisphere, but your formula card does not, and that's what you're going to get on the test in the SOL. So that's why I just went ahead and did it again this longer way, okay, rather than using what it said. Okay, so let's plug into that. So that's going to be, that's going to be 1/2 times 4/3 pi times my radius cubed times my radius cubed. Okay, my radius, we said, I found it right over here. It's 3.5, so 3.5. And let's put that in our calculators. So that's kind of complicated, so let's go practice that together. So if I go 1/2, and what's the other way to enter 1/2? You can totally just put 0.5. If you put a half, scroll out of it, and then we had our parentheses because we were doing half of the whole volume of a sphere. So that was 4/3. Scroll out of the denominator, pi times our radius, which we said was 3.5, close parentheses. When you want to raise it to a power other than 2, you're going to push this button and it lets you enter your power. So we're going to enter a power of 3 there. That's how we do that. I can scroll out of the power and close my parentheses. So look at that. I'm doing half of the formula for volume of the sphere, which is 4/3 pi r cubed. Okay, so that's going to equal 89.8. Is that what we got? Go back and double check. Yes, that's going to round to 89.8. So that's going to be 89.8, and this is volume, so it's going to be cubic units or units cubed. UN is for units, generic units if they don't give us units. All right, we've got our 2 parts. Let's put them together according to our plan. We're going to follow our plan now. Our plan for volume of the composite was going to be volume of the cylinder, 211.7, minus half the volume of the sphere, which was 89.8. If I put that in my calculator, I get that that's approximately 121.9 units cubed because it's volume, 121.9 cubic units. I hope you did well on your composite practice on your own. Good luck with your practice.